Okay, now for criterion C, before starting with the criteria, I'd like to tell you that the original version of the exam, version 1, because I do the first exam and then I start improving it, I actually simplified it for you guys. So in the first original exam, you should be given a table without these values, okay? So only the mass and only the titles. You would for sure be given this part as you did not do the experiment. But this part, you should fill it with 500 gram until you reach 3000 grams. So this is in grams. Then it's up to you. It was your job to convert it to kg. Why? Because you will need it to find the force by plugging it here and using a G of 10. But then I simplified the whole thing, and this was the table given to you in the exam. What you should do was what? You should find the extension. So you add all three values divided by 3, and you will get this on your calculator. Now, everyone started to ask me, what should we do? Should we stick to 2 decimal places or 3? Should I round? Should I write the whole thing? And you should know the answer by your own self. You should not be asking me any question regarding this issue. Why? Because during term 1, we learned something called significant figures. Yes, and any table in this type has a pattern for the significant figures. If you look over the pattern of the table given to us, you will see that it's 3 significant figures. 3 significant figures, 3 significant figures, and not decimal places, because let's take this as an example, okay? So this is to 3 significant figures and 2 decimal places, while this one is also 3 significant figures, but it has only 1 decimal place. So you see how we cannot follow the decimal place pattern in this case, we follow the significant figures, okay? So that's the answer that everyone got it on the calculator. As I said, we need three significant figures. So 1, 2, 3. I should stop here. But before copying your answer, you need to check. If this is greater than 5, then this needs to be rounded up. But since it's 3 and it's smaller than 5, so we will keep it as it is. And this is how you will answer all the answers, and you will fill the table. You'll do the same thing for this one, adding them all divided by 3, adding them all divided by 3, and you will write all the answers here in this table and in this table. Okay, so it's the same exact thing. You add, divide by 3, add, divide by 3, and you fill the tables, the second one, 2.1. Okay, now after you're done with this extension part, you need to find the resultant. How can you find the resultant? Spring K. This is K, extension is E, force is F. We know a relationship linking these three together, which is Hooke's law. We know that F is K times E. So in order to find K, we need to divide F by E. So dividing 5 by 1.33, you should get an answer. Okay, and that's the answer that you will get. Dividing this by this, you'll get 4. Dividing 1.5 by 3.8, you'll get this. And you follow up the same pattern. 3 significant figures. You check the last digit. If it's more than 5, you round up. If it's 5 or less, you keep it the same. Until you reach what? The last one, where almost no one round this up. You need to round this, as this is the purpose of the whole experiment. We want to get this for parallel, and then we do the same exact thing, remember, for the series, and this is what we need to get for series. Okay, so that's the point of the whole investigation. We want to get the resultant constant spring when it's arranged in parallel and the resultant constant spring when it's arranged in series, starting with a K original of what? Of 2 Newton per centimeter. So you can see that that's before reading any other question from the strand. We can see that for the parallel it increased, and for the series the K decreased. Okay, now jumping to this question, they just want you to write one example of how you could find the extension and one example for how you could find the resultant spring constant. Okay, now that's the this is how your graph should look like, and as you can see the graph is very familiar to something we saw before, to this one. Yeah, it's very familiar and it's something that you saw before. Okay, before jumping to strand 2 and 3, let me just firstly show you some samples of how students did the graph. It could be your paper, it could be someone else. I'm very sure that your answer is very similar to this one. First thing, I will check the scale. As you can see here, since you have a table of, since you need to plot two tables, that's table 1.1 and table 2.1. So you need to take into consideration the extension of both tables, this one and that one. So as you can see here, the maximum extension is 7.5. It's true. But if you look over here, the maximum extension is 30. So when he or she wanted to plot the graph for the parallel one, sorry, for the series one, they couldn't plot more than 3 dots up to here only. They could only plot these. They couldn't plot the 20, 25, 30 Newton. And that's wrong. That's not accurate. Even if you get um, a line that is similar to the line that I got, this is still not accurate. So the scale is a very important problem. Also, if I look over this one, this line, it's not a line of best fit. It's either you plotted the points in a very wrong way, or your line of best fit should look more aligned to the points that you plotted. Okay, I don't have a ruler now, but like you should go through as many points as possible. So you need to pay attention over that. Also, what I also got in a lot of papers was stopping the graph on the last point. I don't know why. That's Hooke's law. So it should be something familiar. We know that it should go through the origin. So you need to continue it. And if not, then it's a best fit line. A best fit line is a line. It doesn't end at a specific point. It should continue. Okay? Third comment is that you need to have the Newton and the centimeter, the units of whatever you're plotting. Also, you can see how here the extension to force and here it's force to extension. I don't know why. Anyway, so back to my answer. That's the correct answer. You should have a good scale. I have a good scale. I named my x-axis and my y-axis. Okay, and if you look over here, that's the y, that's the x. Okay, and then I plotted both graphs and I have a key for each graph. I know that the parallel one is this one and the series one is this one. Okay, now strand II, what did you notice from whatever we've done? This is what they want. They want us to interpret, explain, and compare. I told you to compare because I know that we have a graph of two lines. Still, few of you only compared. The others were just, I don't know what they did. They just wrote anything. So using the information, interpret, explain, and compare. First thing I can get from the graph is what? Let me write them here. First thing is that F and E are directly proportional. Okay, that's based on Hooke's law. Second thing I noticed is that the parallel one is steeper than the series one. That's something I can visually observe it. Third thing is something I already know in my brain, which is what? We know that the steeper the slope, the stiffer the K, right? So how can I relate all of these things together to get the answer? We say gradient of the slope of the parallel combination is steeper. The steeper the slope, the stiffer. The resultant constant of the parallel is then greater. And how can I see this? It's here. You can see that, as I said, it was 2, it increased to 4, and it was 2, it decreased to 1 in series. So it's greater. And if you want to get a very, 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 very high level, you would say this thing doubles and it halves. Because if you look closely over here, you would see that we started from 2, ended to 4, so it's times 2. And we started with 2, ended with 1, so it's divided by 2. So this one is doubled, while this one is half. Okay? Now, last thing is referring to the evidence, state and explain. State and explain whether the hypothesis predicted is correct or wrong. So let's see where's my hypothesis. I think this one. No, this one. Yes, that's my hypothesis. If two springs were combined in series, then the resultant spring constant will be lower than the original one because the extension will be greater. So I stated why, because extension is greater. And as Hooke's law states that constant spring is inversely proportional to the extension when applying a force. And this is exactly what you need to write in order to get the answer or the mark. So first thing that I will see is whether you said that it's confirmed correct or wrong to get the answer. And then how did you notice that's correct? How did you notice that it's wrong? By comparing the gradient or the slope of series and parallel, we can see that after calculation, K resulted in series was 1, which is 0.5, while in parallel, which was 4, it's 2K. This proved what Hooke's law, that states that the extension and K are inversely proportional, and this is why the extension in series was greater than the extension in the parallel, while the K in parallel was greater than the K in series. Okay, so that's what the actual or the good answer would look like. Now, if I look over your answers, okay, some student answer, you would see that almost everyone stated the correct thing scientifically. Like you were telling me how force affects the extension. I already know this. We've already done this in the experiment of Hooke's law. And we know that it's correct. We know that the extension is affected by the force and they are directly proportional. Okay? So no matter how long your answer is, or how detailed your answer is, or how scientific stuff your answer is having inside or explaining, if you're not hitting the target, then you're not getting the mark. Okay? So what I need to see here, and the answer is how did IV affect my DV? That's all I want to say. That's all what I want to get from the investigation. I want to see how changing the combination of the springs affects my resultant constant. So if I don't see the word changing combination or series in parallel, and I don't see how k is greater, k is less, k is I don't know what, anything, then you won't get any mark. So the graph for the table was very steep. Yes, you got something for this. Everything else is correct, but it does not relate to my DV or my IV. Same thing here. When the spring were in the parallel combination, they used a lot of force. I don't know what does that mean, but did not extend a lot. Okay, that's true. But how is this related to my DV? You did not continue. You did not reach my target. Okay, you're still somewhere like in between. Why the series combination? They use a lot of force and stretched properly too. In the series combination, the extension is equal to the force. This is shown in the force directly proportional to the extension. This is correct scientifically, but not for my experiment. Okay. This thing, I saw it again. Yeah, that's not this. No, I don't know. This is no. This is wrong. The whole thing is wrong. What? Both? Yeah, both combinations have a positive correlation between extension and force. The series has a larger extension when what? I don't know, to the force compared to the parallel. Again, how does this link to my DV? So you're not, all of these answers are 4 and below. I'm just showing you. Okay, by observing everything on the graph, we can tell the force and extension, as Hooke states, it's directly proportional because when a force is applied, the extension will be less. But when added force, the extension increases. I didn't get anything from that. I don't know. Anyway, so that's for II. For triple I, same thing. I need to see, state, and explanation. Now you can use the Hooke's law thing. Now I'll tell you what to write here. You need to write that, okay, first hypothesis is correct. Then you say, yes, we could prove that in series it's less than in parallel. The K in series is less than the parallel. How could we prove this? Because extension is series was more than the extension is parallel. And this links to Hooke's law, because K is F over E, so K and E are inversely proportional. Okay, so I'm just showing you some examples of the students. I'm pretty sure that if it's not your paper, you got something very similar. You're not hitting the target. This is why your marks were not as expected. Okay, so again, not related to IV nor DV. You see, your answers are correct scientifically, but they're not what I want or what I need. Anyway, so that was everything. I hope this was helpful for you guys. If you have any question, you can still ask me, and I'll see you soon, hopefully. Stay safe and take care.